Again, this is Taylor Anderson. I'm a product manager with EC2, and thanks for announcing our title here. I'm going to just jump right into the presentation with my clicker, see if this works. All right, so what should you expect from today's session? Well, you should learn how to automate AMI building and deployment. We'll also show you how to monitor your fleet configuration and software inventory. And then finally, we'll show how you can ensure that your instances are patch compliant. So when we began creating EC2 Systems Manager, it was really based on a lot of feedback that we'd received from customers. And we heard repeatedly from customers who are migrating to the cloud that managing cloud and hybrid environments, that is instances located in EC2 as well as on-prem, using traditional tools was a complex and costly endeavor. And a lot of that feedback related around 4 key points. The first being that a lot of tools that customers had successfully used on-prem over the years to manage their instances didn't really map well to the cloud. And secondly, managing resources at scale is difficult, especially with EC2, and one of the inherent benefits is the elasticity and scalability. Those capabilities often presented challenges with traditional management tools. Another challenge we heard was lack of visibility into configuration and execution history, particularly when you're trying to get a composite view of instances running both in EC2 as well as on-prem. Having that single view sometimes was hard to obtain. And then finally, we also heard from customers that many had built best-of-breed solutions composed of a patchwork of vendors, which led to its own headaches regarding ongoing management of those systems as well as licensing complexities. And so those are really the key drivers for creating EC2 Systems Manager, which we launched at reInvent in December of last year. EC2 Systems Manager is a set of capabilities that enable automated configuration and ongoing management of your instances and systems at scale across all of your Linux and Windows workloads, regardless of whether they're running in Amazon EC2 or on-premises. All right, so what exactly are the Systems Manager capabilities? There's 7 of them. I'm going to throw them all up here on the screen, and then we'll touch on each of them briefly with a description. On the left, you'll see Run Command and State Manager. Now, those are 2 capabilities that we're going to be covering. These are fundamental capabilities within Systems Manager. Run Command was released a year and a half ago before we added it to the Systems Manager suite, and it supports remote command execution at scale. So some great examples are if you want to be able to run a shell script or a PowerShell script against tens, hundreds, even thousands of instances to do something like install software or configure the instance, you can do that using Run Command. We have a variety of different commands we support, things from joining a domain to updating AWS agents and components. So Run Command is a very foundational service, and it even supports ability for you to throttle execution. So we'll definitely cover that in our session that we're going to be hosting next month with Ananth. If Run Command is an ad hoc way to execute commands across instances at scale, then State Manager is its persistent cousin. So if you want to repeatedly apply a configuration policy to an instance, again, to ensure that particular ports are open or closed, or that a particular piece of anti-malware software is installed, and then you want to go out and monitor compliance, you can do that through State Manager. With State Manager, you can schedule repeated application of a particular policy or configuration. So 2 very foundational services there. On the right, we're going to be talking about these 3 capabilities in today's session. So we're going to be talking about automation, which allows you to orchestrate a series of steps, which may include things like run commands, or even Lambda functions. So one of the core use cases we'll be looking at for automation is Omni maintenance. On the right, we're also going to be talking about inventory, which allows you to gather things like applications from your instances. And then finally, we're going to be talking today about Patch Manager, so how you can update and maintain patches or patched instances throughout your fleet. The shared capabilities in the middle, two more great capabilities that actually can be leveraged by the columns on the right and the left, include maintenance windows, which allow you to schedule what are otherwise disruptive activities. With maintenance windows, you can set up a schedule and then define the tasks that you would like to execute against a set of target instances, which are normally ID'd by tag. So maintenance windows pair nicely with Patch Manager. And then finally, Parameter Store, which is a great way for you to securely store secrets, connection strings, other parameters that you want to share, but also have controlled access to. And Parameter Store is great. It works with IAM, so you can, on a granular level, control who can see what parameters and whether they can read or write to them. So this is an overview of the 7 capabilities within Systems Manager, and really the rest of our session today is going to be a deeper dive on the 3 on the left. All right, so let's start off with automation. So before we created automation, we heard from customers who were in the as far as the cattle versus pets world, customers who are really looking at trying to maintain immutable instances. So this would be more along the lines of the cattle world. Customers who needed to repeatedly update their AMIs. A lot of manual effort can be involved if you're doing that without automation. So a lot of triggers that would induce customers to need to update their AMIs. There's a new release that comes out from EC2. A lot of times customers would harden their own golden images from that, or they need to do some kind of application bake-in. And so there's really kind of an ongoing process of repeatedly needing to take a source image and then modify it and create a golden or production image. And so this, customers told us that this can be a time-consuming process, especially when builds fail. And there's also an overhead of maintaining a service as well. So we found this would be a really great opportunity to simplify this process for customers. And so we created this automation capability within Systems Manager. And again, it's perfect for updating AMIs, or even doing instance deployment and config, and automation comes with the ability to actually be proactively notified during an image creation process, or really at any step through an automation workflow. And of course, because it's an Amazon EC2 service, an AWS service, it's optimized to work with a variety of other services, including Lambda, CloudTrail, IAM, and CloudWatch events. So, and of course, another great benefit is that you don't have to do anything to maintain it. It's a managed service. Okay. So how do you get started with automation? 3 core steps here. You can create a workflow or an automation document, or now you can invest, which we'll look at in a second. Next is to execute that automation or workflow and then monitor the results. So we're going to go into the demo now. Quentin, can you flip it over? Thank you. Very fast on the switch over. Thanks, Quentin. So I'm in the EC2 console, and a lot of folks may spend most of their time, well, in the upper section of the left nav here. Maybe you spend a lot of time looking at the instances view. If you haven't scrolled down to the bottom of the left nav in a while, you should check it out, because that's where Systems Manager lives. It's like a great restaurant that you learn about over time, right? So here we've got a variety of Systems Manager capabilities here. And we're going to start off with this item here called automations. Now, I've run some automation workflows before the session today, and so what I'm going to do is I'm actually going to look at some that I've already executed as a great starting point to help understand what the capability is of automation. So you can see here I clicked on this item here called AWS Update Linux AMI, and when you see a document, and we'll talk about documents in a second, when you see a document that begins with AWS, that means that it's a managed document by AWS, and so you can use this right out of the box. And so we can actually look at what steps are in this workflow here. If I click on steps, and again, this is a workflow I've executed previously before a session today, we can see below that we have 5 steps here, okay? So we have launch instance, and then I've got another one, update OS software, stop instance, create image, and terminate instance. So what we're doing here is that we're launching an instance with a source image, and we're using one of these supported action types. So automation supports a variety of action types, which we'll go over in the presentation in a second. But one of the action types is run instances. So one of the arguments we'll pass in here is a source ID, AMI ID. And then our next step here is to update the operating system software. So here we're actually using run command, which I referenced earlier. So remember, run command allows us to execute commands remotely on a target instance. And so in this case here, we're actually running a series of a shell script to update the package operating system here. And Update Linux AMI will work for a variety of different Linux distributions. And then the next step here, of course, before we want to create an image, we want to stop that. We're going to use the change instance state action type, and then we're going to create the image. And then we're going to terminate the instance. And the result is a new image. So if we wanted to execute this document or execute this workflow, what we would do is we would go up to the Run Automation button and click that. And you'll see here that Run Automation presents us with a variety of automation workflows or documents. Now, I've created several on my own, but you can see the very first one is the one that's provided to us by AWS. So if we were to select that document, and again, we can right out of the box, we don't have to create a workflow, we can just use a pre-built one. Then we scroll down, and we can see that we have some parameters here that are passed into this workflow. Some of these parameters are pre-populated with default values, a few are not. So for example, the first parameter that we would need to execute this workflow is the ID of the source AMI. And then we need to pass in two roles here. So these roles, one of these roles is the instance IAM role. This is the role that provides us with the ability to actually execute run command against this instance. And the next is the automation assume role. This is in ARN that provides automation with the authority to execute within our account. So these two roles can be generated using a CloudFormation template that's in the technical documentation. And we'll take a look at the technical documentation in a second. So once I provide these parameters, I click Run Automation, and then this workflow is going to go ahead and execute. I'm going to cancel out of this because depending on the amount of patching that's being applied, we may go through a little bit longer amount of time to run the second step. So one of the great things about starting off with a reference document is it becomes a great point for you to go ahead and create your own custom workflow. So for those of you that are Windows shops, I have a custom document that I've created called Patch Latest EC2 Windows AMI. So I've clicked on that, and now we can see I've run this previously as well. We have a slightly different set of steps. A lot of these steps look very similar to the Linux equivalent that we just looked at with start instances, install, update, stop, change, and terminate instance. But we have a new step at the very beginning of the workflow. And I call this Get Latest EC2 Windows AMI ID. And you can see that we have a different action type here called and I got a little bit lazy, to be honest, about going out and retrieving the latest AMI ID each month. So I wrote a Lambda function to do it for me. And so this Lambda function goes out, and I pass in the version of Windows I'm interested in, say Windows 2012 R2, and this Lambda function goes out and gets the AMI ID for me, the latest one released by EC2, and then it goes through this patching sequence. So if we want to see, if I wanted to run this, we're going to see that the parameter set is a little bit different. And I'm going to find my documents, patch latest EC2 Windows AMI, and you can see here I only have 4 parameter values. So what I did is the roles that I needed I actually baked into the document. And so here's the Windows version that I'm passing in, Windows 2012 R2 English. So that's the version of Windows that I would like to get the AMI ID for. And then here's the source AMI ID, which is actually provided by parameter store. So the Lambda function writes the AMI ID to parameter store, and then that's actually my default value for the source AMI ID. I put in region, and then here's the target AMI name. So patched AMI, and then you can see we've actually concatenated a couple of things in here in the name. So when we create this image, we'll have a record of the date and time when this image was created. So just briefly to drill down a little bit more on documents, because that's really behind the scenes how we define the workflow here. And there are a couple of different document types within Systems Manager. We have a document type for automation. We also have one for run command as well. If I were to go into documents, and I were to click on documents owned by me, and then I'm going to click on patch latest EC2 Windows AMI and click on content, we can actually see what goes into an automation document. Now these are written in JSON, and a couple of things we would expect at the beginning of this document here. So a description, schema version is 0.3, that's fixed right now. And then the parameters we're passing in. So these parameters actually map to the parameters that we just saw in the console. So version ID, AMI ID, region, target name, etc. And then the next step of the document defines the steps here. So here we can see the step name, which maps to what we just saw, and then we can see that we actually have some controls over timeout and things like that. All right, so that's enough of our automation demo. Let's jump back to the presentation, Quentin. All right, so as we saw in the demo with automation, we can declare input parameters, and we can also optionally declare output parameters. So if we wanted our automation workflow to return something like the ID of the new image, we can do that as well. And we just looked briefly at our parameter store integration. So if there's parameters that we want that allow us to avoid, for example, hard coding values into our automation workflow, or allow us to declare defaults so we don't have to enter parameters manually. Parameter store makes a great integration. By the way, parameter store also integrates with State Manager as well as run command, and also can be referenced as well in Lambda functions. We also support system variables, so as we saw in the AMI ID name, we support date time. You can also reference date, region, or execution ID as well. And then in the demo examples down below, you can see how we referenced within the JSON the parameter store in those variables. So what are the other action types for automation? Well, we saw run instances, we saw change instance state, we saw create AMI, we saw run command, we saw invoke Lambda function, a couple others that we didn't present today. Also the ability to copy an image and create tags. So copy image can be pretty cool, especially if you want to do a cross-region copy. What it's going to do is effectively we'll do a pull from a source region and create tags if you want to tag a resource. For example, if you want to tag that worker instance that you launched to build a new AMI, you can do that. Or if, of course, you want to create attach tags to the new image that you created as well, you can do that as well. And then with each step, you can define the number of retries, timeouts, and if you want to continue or abort based on whether a particular step fails or is successful. And then, of course, it's really easy to get started with Update Linux AMI, and in the coming weeks, we'll be releasing its counterpart, Update Windows AMI. With automation, there is a bit of work that you'll need to do with IAM. You'll need to create a service role for automation that provides permission for the automation service to operate in your account, and also attach pass role policy. And you'll need to launch instances with an SSM role. Again, the documentation includes this. Quentin, can we jump back real quick to the demo here, because I want to show this in the documentation. So we have an entire section dedicated to Systems Manager, and each one of the capabilities is covered in here. So I've opened up automation, but want to look at maintenance windows, or how to get set up with automation, how to work with documents, inventory patch management. It's all in here. And by the way, if you want to look at more automation examples, we wrote up some examples that we get a lot of questions on. So if you're a shop that's using a Jenkins server and you'd like to be able to use automation to actually create an AMI, we've got an example on how to do that as part of your CI/CD pipeline. Here's another example here, how to patch an AMI and update an auto-scaling group here. So in this example, we invoke a Lambda function to update a launch configuration. So lots of great examples here in the documentation as well, really for all the different systems manager capabilities. Okay, thanks. All right, so let's jump back to the presentation. We'll go to the next slide. Thank you. One more thing I wanted to mention. We do have an integration with CloudWatch events with automation. So if you want to be proactively notified when your workflow completes and be notified only if it's successful or only if it fails, you can configure CloudWatch events. If you want even more granularity, you can configure CloudWatch events to send you a notification at every step. So whether a step is successful or failed, you can do that as well. We got that feedback from customers who are doing patching, that they really want to be notified as soon as a particular step failed if it did. All right, let's go on to our next slide. Inventory. All right, how are we doing on time, Quentin? Good. All right. Okay, so what do we hear about inventory? Well, we heard that it's really, really critical to have an accurate picture of software inventory across the fleet, particularly when working with folks in the compliance department. And again, we heard that legacy solutions, well, they're not necessarily optimized for the cloud, especially the scalability. And if we want to host our own inventory solution, that requires its own amount of overhead. So again, getting back to the benefit of having a managed service with AWS. So with inventory, you get end-to-end inventory collection, works with both Windows and Linux instances. And then once you've actually collected that inventory across all your different instances, you can run queries against it. And in addition to that, we offer an extensible inventory schema. So if you want to collect exotic attributes from your instances that we didn't cover or include in our initial inventory schema, you can do that yourself. And of course, this is integrated with other AWS services, as we're going to see in a second, like AWS config and config rules. All right, so here's a systems diagram of what's going on behind the scenes. How do we actually get inventory from instances? What we do is we start off by creating an inventory policy effectively, where we define what inventory we want to collect, how frequently we want to collect it, and the instances we would like to collect inventory from. That policy is sent out to different instances that you've targeted in that policy. And then there's an agent that runs on these instances. So this is the SSM agent, and it's a required ingredient for any instance that you want to manage using Systems Manager. So if you want to run command against an instance, you want to use State Manager with an instance, you want to collect inventory, you want to patch, those instances need to have the SSM agent in them. And by the way, the agent is baked into all Windows, EC2 Windows AMIs. If you're a Linux shop, you'll need to add it in. There's examples and the documentation of how to do that using user data, or if you're the kind of shop that maintains your own golden AMI, then you can bake it in once and just maintain it going forward. So all of these instances have an SSM agent on them, and they also have an SSM role attached. The SSM role authorizes an instance to communicate with the Systems Manager backend. And by the way, SSM is the namespace for Systems Manager. So you'll see that term SSM referenced frequently when it comes to Systems Manager. All right, so this policy is pushed out to these different instances, and then the agent responds back with the inventory, and that inventory goes back to the inventory store. Now, optionally, if you want, you can take advantage of the integration with AWS config. So inventory provides a point-in-time snapshot of your inventory picture. But if you want to go back on a historical record and be able to identify state changes over time, you can use AWS config to do that. AWS config is a great service that allows you to monitor state changes to a wide variety of AWS resources, including EC2, S3, RDS. Also includes a capability for you to monitor changes in inventory. All right, so how do you get started? Well, you would configure an inventory policy, then you apply the policy, and then you query inventory. So let's jump back into the demo. Okay, so now I'm going to jump to managed instances. Okay, so these instances are those that have, again, the SSM agent installed and have been launched with the SSM role. Now, for those of you who maybe didn't hear, about a month ago, EC2 released the capability to attach a role to an existing instance. So if you have instances that are long-running instances and you'd like to get them under Systems Manager, you certainly can do that Just need to get the agent installed, and then you can use that new EC2 capability to attach a role to a running instance. Once you do those two steps, the instance will present a heartbeat back to the Systems Manager backend, and it will appear in this list of managed instances. So once we have a managed instance, we can go ahead and click on it, and we can do some pretty amazing things. So for example, I'm going to click on this second instance here, and I'm going to click on inventory, and I'm going to click on AWS application. And so now I am looking at the packages on this Linux instance. And if I want to, I can go ahead and run a query against this particular instance. So let's say I want to see if Python's on this instance. I can go in, I can click on name, and I can click on begins with, and then I'm going to type py, and I can see that this instance has Python 2.7 running on it. And if I go over here to the right, I can also see when this inventory was last collected. So it was collected today at 9 a.m. So now this instance is one that I've already set up to collect inventory. So if you create a large number of managed instances, you're going to need to go through your own inventory setup process. How do you do that? Well, we make it pretty easy with this button, set up inventory. So let's go ahead and look at what that looks like. Okay, so I'm in setup inventory here, and my first selection here is to select the targets. Targets are the instances that I would like to gather inventory from, and I can either specify those instances via a tag or individually using instance IDs. We recommend you use tags to do this for a couple reasons. One is that tags allow me, for example, let's say I set up my inventory collection today, and 2 weeks from now I launch a new instance. If that new instance carries the tag that I've defined here, then that instance will automatically get picked up and will also begin reporting inventory. So we recommend you use tags. Once you select your targets by tags, let's say I just do patch group, and I'm just going to select PG1. The next item here is to select the schedule. So I can collect inventory as frequently as every 30 minutes, or I can spread it out and do it, say, at Saturday at 1 in the morning. And then the final item that I'm going to select will be the parameters or inventory types that I'm going to gather. So I can collect the applications. I can collect the AWS components. These would be AWS agents and drivers. Network configuration, and then if it's a Windows instance, I can look at any Windows updates that are on there. And then finally, I can optionally collect custom inventory. Here's how custom inventory works. There are 2 ways for you to push custom inventory data to the inventory store. The first is you can use the put inventory API directly, and you would pass in the instance ID and then a JSON blob with whatever parameters you would like to put in. So as I mentioned earlier, we support both on-prem and EC2 instances. So for example, if you had an on-prem instance and you wanted to append a rack location or something like that, you could actually do that using custom inventory. You could do it using the put inventory API. Separately, you can also have the instance directly report custom inventory itself. What you do is you'd set up a scheduled task or a cron job to write a JSON blob to a specific path. And then our agent, every time it runs a collection, is going to go look in that path. And then if it sees a JSON file there, is going to also report that custom inventory up as well. All right, so that's how you would set it up. I've already got all my instances reporting inventory, so I'm going to cancel out of this, but it's a pretty straightforward process to begin collecting inventory. And so if we go over here, again, here are some of the other inventory types we've got. If I want to look at network, we've got some networking detail, AWS components. Here's some agents that are installed on the instance. But let's say we want to run a query against, well, all the instances that are reporting inventory. Let's say we want to find instances that have Microsoft.NET on them. So I would go to name, and I'm going to go with begins with, and then I'm going with Microsoft.NET. And I see that I've got, well, 3 instances. One of them is disconnected. This is a managed instance, which I've terminated. But I can see that I've got 2 active instances that have Microsoft.NET on them. And let's say my organization has decided to standardize on .NET 4.6, and I want to find all instances that are non-compliant. That is, all instances that are less than .NET 4.6. Well, I can do that as well. I can add another filter here, and I'm going to click on version. Oh, and it turns out that both of these are less than 4.6. Actually, they're running 4.5, but you get the idea here that this is a pretty powerful way to be able to go out and understand what instances are on a particular version or less than a version that you've identified as the one you're standardizing on. Okay, so I'm going to clear out of those filters, and I'm going to scroll to the right here, and you can see that we've got an icon here called AWS Config. So let's see what that does. I'm going to click on that icon, and it's going to take me, we just opened up another window here, and this is the AWS Config console. And so previously we were looking at the software inventory of an instance for a given point in time, an instance. And here we've got a timeline. And what this timeline shows us is it marks every date and time when a resource changed. So again, AWS Config supports a variety of resource types they track, really fundamental ones like S3 and EC2 and RDS. Also support the ability for you to track managed instance inventory resource types. So this is great for shops that want to know what software, what inventory changed when on an instance. So we can see here, it looks like we had an event on April 18th. I can click on that to see what happened. Click on it. Changes. And we can see here that we installed a couple of KBs on that date. One of the other really cool things you can do is you can actually look, for example, on any given date, you can look at, let's say, the installed applications. So let's say I want to know what the installed applications were as of March 25th, because we had a change there. We can go in and I can see, oh, all right, we got, well, EC2 config service. We've got some other tools for Windows, AWS PV drivers. So I have a list of all the applications that were available on a particular date. All right, well, this gets even more interesting because I can also create config rules. So config rules allow me to monitor or set conditions which I would like to be notified if we reach, for example, a non-compliant condition. So if I go to AWS config and I go to rules, I've set up a single rule here. And this is a managed rule, which means that AWS config has about 20 or 25 rules to choose from. I just pulled one right out of the box. And this is managed instance applications blacklisted. So I want a rule that's going to go out and look for blacklisted applications. And in this case, I decided that Python was my blacklisted application. And you can see here that all the instances that we're monitoring with this rule are actually compliant. So in the event that one was non-compliant, that would be a useful piece of information. I could turn around and act on that. So this really provides a proactive way to help you monitor for compliance across your fleet. Very powerful integration. One thing to note, that while Systems Manager, there's no additional charge to use Systems Manager or any of the capabilities within Systems Manager, AWS Config is a fee-based service. So if you want to go ahead and take advantage of this integration, there is a fee associated with it. Okay, let's jump back to the slides. Thanks, Quentin. We got 25 minutes left. We're looking good on time. All right, so just to wrap up on inventory here, we also enable custom inventory collection. So if you want to go ahead and gather specific inventory attributes, you can do that. We talked about that a little bit. Either you can make those calls directly using the put inventory API or by running a cron job or a scheduled task on the instance that writes a JSON file to a predefined location, and then that'll get picked up automatically by the agent when it reports inventory. And we talked about query. You can search by inventory attribute, partial inverse searches, and we covered our integration with AWS Config. All right, so let's move on to the final service here, which is Patch Manager. Well, what do we hear about Patch Manager? Here's another exercise that can be time-consuming, tedious, and repetitive. And we also heard from customers that they weren't necessarily happy with solutions that were out on the market, and if they were using one of those solutions, now they were back to hosting the service and maintaining it, patching it. And so, again, interest in an AWS managed service. So we developed Patch Manager, which provides end-to-end patching. Initially out of the box, supports patching for Windows operating systems. We've got a huge number of requests out there for support of Linux, and we've heard those requests loud and clear. Patch Manager is easy to operate, and again, it also integrates with other AWS services. So how do you get started with Patch Manager? Well, you create a patch baseline, which is really a rule or set of which executes those rules or applies those patches, and the maintenance window executes according to the schedule, and then you can audit the results with patch compliance. So for the rest of our session today, we're going to drill down deeply on each one of these steps. Created a diagram here because there are multiple moving parts here for Patch Manager. So as we're going to see in a second, patch baseline, you're going to create some rules based on attributes that are important to you regarding the criticality or the age of a patch that you want it to attain before you'll consider applying it. And then the schedule for your maintenance window, and then once this is all completed, you'll be able to look at your patch compliance to see your results, to see how you did, to see if any of those patches were yet not applied for some reason. All right, so Patch Manager, this is really an auto-approval methodology for patches, and you're going to create rules. You can have one or more rules. So you're going to, again, state the particular product you would like to generate a list of patches for. So it can be, right now, a particular flavor of Windows, or it can be all versions of Windows if you want. The MSRC classification, so for example, critical, and again, how long that patch has been around for before you'll consider approving it. You can also blacklist patches. So let's say you have a known compatibility issue with KB 123456. You can blacklist specific patches. Or alternately, if you decide that your organization just whitelists specific patches, you can use that as an alternative method as well. And then you're going to go ahead and you're going to register the target instances using a tag called patch group. So once you define that patch baseline, okay, and the patch manager is there and it's generating those lists of KBs or patches, right? We need to get those applied to an instance or instances. And so you're going to do that actually using another service called maintenance windows. Maintenance windows can be used for a variety of maintenance activities. One of the great use cases is to use them for patching, and I'll show you how to do that. You can develop a schedule, either using the console to define the schedule, similar to how we set up that schedule for inventory, or you can write a cron expression. Again, you're going to define the target instances and any tasks. So right now, maintenance windows support run command as the primary task. So once Patch Manager executes under the maintenance windows, you'll go ahead and see those patches applied, and then the last step, of course, is to see how well you did. So at this point, we're ready to jump back into the demo. Great, thanks, Quentin. So I'm going to close out this view here from the AWS console, and now I'm back in the EC2 management console. All right, so I'm going to start off with patch baselines here. I'm going to click on that. All right, so I've already defined a couple of patch baselines, but I'll show you what the process looks like to create a new one. Of course, we'll start off by clicking the button, Create Patch Baseline. So I'll come up with a name here, Demo 5. I'm going to bypass the description, and I have the ability to select the product, the classification, the severity. So let's say I want the severity to be only critical patches, and I'm going to go with all products. I have a choice of if I want to just generate patches for a specific flavor of Windows, but I'm going to stick with all. And we have different classifications to choose from here, so critical updates, security updates, service packs, etc. And again, here's the delay here, so maybe I want my patches to mature for 5 days before I'll consider them. And then, I don't know, KB 1, 2, 3, 4, 5, 6 is a patch we don't like in our organization, so we don't want that. We want to make sure that's blacklisted. Next step is I create a patch baseline. And then once I create that patch baseline, right, we need to tell Patch Manager what instances to apply that baseline to. So Patch Manager requires you to create a tag called patch groups, and then we go ahead and we're going to modify patch groups for this. So we're going to say, let's say, I'm going to say I've got a patch group and I've created a patch group called PG3. And what that means is that when this patch baseline is applied, it's going to be applied to instances within the patch group PG3. So maybe you have instances that are in your dev environment or your prod environment or front-end servers. You could use whatever tagging scheme you want to really control the granularity of how these different patch baselines are applied into which instances. Okay, so we've set up our patch baseline here. And again, the output of the patch baseline will be a list of patches. The next step here is to set up a maintenance window, right? When do we want these patches to be applied? So I'm going to go to maintenance windows, and I've created a couple beforehand here, but I'll go through the process of creating a maintenance window. So I'm going to call this demo maintenance window 5. And if I want to do a cron rate expression, I can do that, but I'll just go with a schedule builder. And let's say my organization, we like to patch Saturdays at 1 in the morning. And our maintenance window is 4 hours. And you know what? We want to stop initiating new tasks 1 hour before the end of the maintenance window. So when the maintenance window ends, we're not going to terminate any progress patching. We're going to let those run. But I don't want to start anything new 1 hour before the end of the maintenance window. One of the questions we get a lot about Patch Manager is regarding reboots for instances, and anytime we apply a patch to an instance, we're going to reboot that instance. All right, so we're going to create the maintenance window here. And then the next thing I'm going to do is I need to do 2 more things for this maintenance window. I need to register targets, and then I need to register tasks. So when I register targets, that's going to be using tags, and I would want to use the same patch group that I used earlier. Well, I'm going to go with PG1 since that's actually a real patch group in my account. So now I have agreement between the patch baselines, right? What I want is I want agreement between the tag I'm using for the patch baseline and the maintenance window, okay? So I've used PG1. I actually have separately a patch baseline that also uses PG1. So I've created my maintenance window. I've identified the targets. And then the last thing is to register a task, right? So by registering a task, remember we said that we can really execute any run command. But in this case, we're going to execute a run command that's going to use AWS apply patch baseline, okay? So we're going to stick with it. It happens to be the very first item on the list, and that's a great default for us here. And we can select task priority, and then here's the registered targets that I created earlier, okay? So my targets are already selected. And then I can choose to either scan or install patches. And maintenance windows requires a role, which I've set up previously. So we've got maintenance window role, and then I can also throttle the patching execution, right? So there's a concurrency threshold that I can state. So if I've got 100 instances, I can say, you know what, I just want to patch no more than 10% at a time, or maybe 10 instances at a time. I can select it either way. And I also have the ability to stop patching operations if I hit an error threshold. So let's say, you know, if I have 100 instances and I say, hey, if I get more than 2 patching errors, I want to stop all patching operations, then the patch operations will stop based on this parameter here. And I can write the output to an S3 bucket. All right, so I'm going to cancel out of this because I've already got patching set up in my account. So we've done 2 of the 3 steps so far. We've set up the patch baselines. Those are the rules. And those rules are going to translate to a list of patches. and we've set up the maintenance window. So we've scheduled when those patches are going to apply, and we've set up controls over how many instances we're going to patch at a given time, and whether we want to stop operations if we run into errors. So the last item here is to check our work, really to look at patch compliance. And this is a new release capability here. So I'm going to go to patch compliance, and I'm going to do this based on patch groups. And I have a real patch group in my account that I've been using called PG1. And you can see that I have 3 instances in PG1, and they're all up to date. So what patch compliance is going to do is it's going to look at the patch baseline, the list of patches that we want to apply, and then we're going to look at the actual patches on an instance, and we're going to do a diff between those two, right? And if they agree, then it's going to show up as a compliant instance. If I want to, I can drill down on any one of these instances here. So I've got 3 instances that are up to date. I've got 3 instances in patch group 1. Here they are all below, and if I click on one, it takes me back to the inventory view here. So now I'm back actually in the managed instance view. You can see I'm filtering by this instance ID. And I can click on patch here, which is a tab adjacent to the inventory tab we were looking at earlier. And we can see all the patches that are installed on this instance. And if I want to, I can even filter them by, for example, classification. Let's say I just want to look at the security updates. Boom, there they are. So you can see that what we've really done to support patch compliance is we're also maintaining an inventory of patches on the instance as well. Okay, that's it for our patching demo. Let's bring it home here. So there it is, fleet-wide summary of patch status. There's our demo. And that concludes it for our session today. With our last slide here, I wanted to cover a couple of key resources. As we looked at earlier, we've got a lot of great documentation out there on Systems Manager that includes not only the capabilities we looked at today, but other foundational capabilities, including Run Command, State Manager, and Parameter Store, which Anant is going to be running a session on next month. So be sure if you're interested in remote command execution, managing your instances, especially if you want to get off having RDP or SSH connections, leaving those ports open, Run Command is a great alternative for you. Check out that documentation online and also the latest user guide. Hey, it's been a great session. Thanks everybody for joining. We're really excited about Systems Manager and we hope you are too.